So we're going to do a kind of a series of epoxidation. Right? Following epoxidation is also hydroxylation. You can use what you know from epoxidation, right, to hydroxylation. This is how we do that. Let's say we have this, and we know that MCPBA is going to form an epoxide. Here, well, let's form an epoxide here. Now, if I add that to H plus and H2O, just like we would have done with hydration, but if we add this to this, what happens? Well, I see. First, the oxygen here is going to react as the base. So we're going to use the oxygen, attack the H plus, and here we have this. To H plus. Right. Okay. By doing that, now electron pool is trying to go towards oxygen because oxygen hates being positive. What else do we have over here? We have water, right? Water is going to assist with that by pushing the electron density, because we want the carbocation to be where? At the most stable, which is at the tertiary here. So electron density is going to move down, right? Just like what we learned about epoxides. It wants to move down. By doing that, now we have this over here, and of course, if it's moving down, it's going away from you, and the new water coming in is going to add another hydroxyl group there, and it's now pointing towards you. Here we have what we call hydroxylation, forming diol. Diol means that you have what? Two OH groups in one compound. Okay? There are other ways to make diols, but not using epoxides. So let's introduce that. You can either use some oxidizing, really strong oxidizing agents, or you can oxidize ozonoses even further. So let's use strong oxidizing agents first. Oxidizing agents are some things that causes something to oxidize or to add oxygen or to lose electron when reaction occurs. So let's see this reaction again using the same compound here. Let's say that we break this with, let's do osmosis first. KMnO4 is a very strong oxidizing agent. When we oxidize this, if we put cold, it reduces the potency of the KMnO4. By doing that, we create diols. Simply under basic conditions, right, we create diols. This is just a matter of you knowing what the reagents are. Right. They're going to be pointing in the same direction. This is called syn addition. Earlier, I taught you about anti-addition. This is syn addition because both of the things you add into the alkene is going to be pointing in the same direction. So we call it syn addition. Another way to do the same reaction is by using something called Osborne. Osborne is this, right, on the peroxide. By doing the same reaction, without going through the mechanism, it will still form this. This is still syn addition, same reaction.
Pause. I need to change battery.
Okay.